All right, we have example 2 where we're trying to go from recursive to explicit. And from explicit back to recursive. How can we relate these two formulas to each other? To start, we just wrote out what the first 4 terms would be when looking at the formula. We start with 3, we grow by 0.5. What you begin with, this is what you grow by. For the explicit, it's just one line. You don't have to do the brace. And it basically ties both of those ideas into one formula. It packages them into one formula that allows you to plug in the term that you want to get to, and it'll give you the output. It'll give you that term number. Here we go. Here's how it works. You start by putting the first number here. Then you tell me what you're adding or subtracting to get from term to term. And right here, it's 0.5. So we're going to add 0.5. And then in the parentheses, we need to multiply that common difference by the number of times you need to add it to get to the term that you want to get to. All right? For example, let's pretend we were trying to get to term number 4. N would be 4. Well, how many jumps or how many additions of 0.5 would it take to get there? If I want term number 4, I need to add 0.5 3 times. If I wanted to get to term number 7, I would need to add the common difference 6 times. So basically, if I want to get to term number n, I would add this difference n minus 1 times. That's what times means. How many times are we adding it? 0.5 times n minus 1. Here, check it out. It works. This is term number 4, 5, 6, 7, 8, 9, 10. Term number 10 should be 7.5, right? As long as I did that correctly. I think I did, yes. So here's what we do. If I want to get to term number 10, I would start with 3, and I would add 0.5 10 minus 1 times. Or I would add a half 9 times. Well, 3 plus half of 9 is 4.5. Lo and behold, 3 plus 4.5 is 7.5. That explicit formula does the job. Part B. Given the explicit formula, can you go backwards and find the recursive? I think I can do that. Let's go ahead and write the AN with the brace. This tells me what I start with. So you start there as long as the n is only 1. If I'm on term number 1, I start with 16. That's where it begins. And then I subtract 3, so 16, 13, 10, 7, 4, etc. This could go on forever, subtracting 3. So how do I say that recursively? Well, you take a n minus 1, which is the next term, or the previous term, to get to any term. You take the previous term, and you keep subtracting 3. As long as you're on a term number bigger than 1. That's your recursive formula. Go ahead and do the triads, to A and B. If you have any questions, let me know. I'm going to pause the video again and reveal the answers. Just revealing my answers here for the explicit formula for part A and the recursive formula for part B. Hang with me for a moment here as I go to the next page and show you what these formulas are, what we just discovered. What we found out were that the recursive formula can be written out in red, where I have there in red, and the explicit in blue. Some definitions. AN is the term that you're on, like the current term. AN minus 1, whenever you see that, that's known as the previous term. N is the term number. And D is the common difference, what it's growing or shrinking by. There's one other symbol in there right here. A1 is the first term. So those are formulas that you can write down in your notebook.